We use the Leokraft proprietary AI, ML, and NLP models to create Speciphic, a retrainable framework for unstructured data. For this demo, we have used some of our components to showcase how we can build configurable systems backed by flexible machine learning models. Let me quickly log into this application to show the key features that we have for this demo. As the user logs in, we take them to a completely configurable dashboard. We have upwards of 100 pre-built statistics and content holders that can be configured as needed. The key components of this application are the requisitions, applicants, and the AI and ML training ground. Here, we have provided a user to create JD or ability to import or schedule from a previously configured source, like an email, file server, or an enterprise system like Workday. Requisitions can be very structured or unstructured. Unstructured is always the harder piece, and so we have selected that for the demo. Moment a job is created, the entire mapped sources are analyzed using the applicable ML models to suggest candidates based off of various parameters. The parameters on which we train are also configurable in our models. Let me click this JD. We see that we have a few applicants. As we add applicants, the relevance is calculated. One unique capability that we can expose due to the nature of our decentralized models is to enable the selection of models too. As of now, we have 7 models applicable for this use case trained. But we can do as many required and create various kinds of interdependent sets. There are various ways to look at data and pin them wherever desired, just showing one where we are doing a source analytics. Note this candidate, Richa Sharma, has an 80% relevance. We have also provided a few important tracking tools here, like keeping any comment about candidates, which in turn we can feed back to the training models to make better affinity checks. A lot of possibilities based on unique needs. We can click the applicant and see all details. The screen can be designed to show all the required key things. As you see, all the history is retained. Let's assume here that we want to edit a few skills and check. Maybe the requirement has changed a bit. We want to shortlist again. What a nightmare. But here we use the deep learning model to immediately re-shortlist here and across available candidates. Let us add a resume quickly. The moment we added it here, it has also analyzed fitment for every other job and will be present in the dashboards. It can be configured with jobs to consider, how to notify, etc. We can configure bulk and background uploads. In real life, all of these applications will flow in automatically as resumes arrive in the queue. They will be classified, tagged, and shortlisted for all and any relevant jobs and presented. Just to show how a job is created, these fields can be configured, or there can be a training model for this too to auto-suggest. Or these can come in through an integration. Just trying to show how things will start to work when a new JD is created or received through an integration. Before we go into the training models, here are a few key things. The application can be designed to learn from every action, like when a high relevance candidate is not shortlisted. We also have other frameworks not shown here that we have developed for web scraping, sentiment analysis, OCR, image recognition models, etc., which may be very relevant too. This is the brain of the system. We currently mostly do things in our servers. This is the kind of do-it-yourself model that we can expose to the admins when they have the ability to add data to train models. We can add a new model that is utilizing existing ones, or we can use various standards and frameworks like TensorFlow, SpaCy, NLTK, Gensim, neural networks, and others to build for the scenario later exposed to end users to train.